Hi there! Today we're going to talk about modern synthesis and how it connects to human evolution. For starters, modern synthesis created the scientific framework for anthropologists to better understand humankind. Now, let's get started. Charles Darwin's theory of modern evolution continues to be one of the most agreeable explanations in academia, not only because it connects modern synthesis to human evolution, but because it helps clarify how and why evolution occurs. As it turns out, just like survival is one of the biggest motivators for conscious human choices, it's also a major factor in the scientific process. We can thank Charles Darwin for that lesson. Although anthropology studies humans, our understanding of humankind originally stemmed from a breakthrough for plants. This breakthrough dates back to 1865, but at the time, it was pretty controversial. Scholars didn't seem to understand all the similarities between plants and humans, and Gregor Mendel was forced to learn this the hard way. Mendel's famous study began with pea plants, when he began with a hypothesis to crossbreed two different colors. He thought that if he crossed a purple-flowered pea plant with a white-flowered pea plant, he'd breed a new shade of light purple petals. To his surprise, his hypothesis was wrong. Mendel ended up with tons of dark purple petals, and a small fraction of them stayed white. He conducted nearly 5,000 trials, but he kept getting the same result. Sound familiar? That's because the result epitomized our earliest biology lessons, when we learned about that Punnett square. Unfortunately, in the 1800s, the Punnett square had not yet been introduced, and biologists were skeptical of this concept. Now, let's talk about why Mendel had so many purple flowers and not that many white. Because purple flowers were the dominant gene, it surpassed the recessive white petal gene in the majority of trials. While Mendel helps us understand how different genetics face off, Charles Darwin helps us understand why only certain genes stand the test of time. The answer is survival. As specific species and subspecies die off over time, they prove their genetics are unworthy of being passed on. In other words, natural selection rejects harmful genetics just as it reinforces the useful ones. Genetics that survive the test of time are considered the most favorable, as they naturally increase the likeliness of the next organism surviving. Here's an example. Imagine if the white flowers were extra sensitive to the sun. Now pretend that it becomes common that the plants die before they reproduce, because they're so damaged from the sun. If the white flowers eventually become extinct and the purple flowers live on, this would be natural selection. Now, let's pretend we're talking about humans again. Although humans don't vary in petal color, we do vary in skin color. And, depending on where you live in the world, your skin color can help you survive. For example, humans near the equator tend to have darker skin. Humans with fair skin also risk overexposure to the sun in these places because they lack the same protective pigment. This increases the likeliness of their fatality before reproducing. And this is another example of natural selection. Species by species, genetics continue to mutate and adapt, but only the strongest will live on. Natural selection is one of the most agreeable explanations we have for evolution. And now that we understand how this works biologically, we can better understand how and why evolution works for mankind.
Created using Powtoon.